Okay. So, hey, what's up, guys, and welcome back to another live streaming. Today, I'm quite late. I was not able to, give the bi-weekly contest on time, but right now I'm live with the virtual contest. I actually don't know the question, what were the questions, so I'll be solving them as a fresh questions. So, let's start without wasting any time. I hope my voice is audible to all of you. Let's start with the virtual contest. Okay, start practicing. Okay, so I actually don't know the question. I just came from somewhere and just started live streaming. So yeah, let's read the question and then solve it. Exactly one consecutive set bits pair. So you are given an integer n, return true if its binary representation contains exactly one pair of consecutive set bits and false otherwise. Return true if its binary representative contains exactly one pair of consecutive set bits. Okay. So the set bits in an integer are the ones present. Okay, got it. So what we have to do actually is first we have to see how this 6 nums is equals to 6 looks in a binary representation. So how will it look? It's 6, so it can be represented in 3 bits. So let's assume we have 3 bits. So 1, 1 and 0. So it's 4 plus 2, 6. So it has consecutive set bits. Yeah. So the answer will be true. For another case, that is 5 nums equals to 5. So the bits will be 1, 0, 1. In this case, it will be false. So you got my question. You got my intuition that how we are going to approach this question. Now, there are no consecutive bits set. Okay. So the constraints are 0 to 10 to the power 5, the value of n. Okay. So let's think how we can find out set bits here. So mm, either we can check for all the bits in a number because you know it's a 32-bit representation. So on the number between 10 to the power 5, yeah, belongs to integer. So what we will do, we'll try to check if exactly one pair. Okay, we need exactly one pair of set bits. If it's more than that, we have to return false. Okay. In that case, for example, we have something like this, and this. So it will have answer false. Why? Because we are able to find multiple consecutive set bits. You can see right over here. We can find it, na? So if it's more than one, so let me write rules. Uh, if we have more than one set bit pair, return false. If we have no set bit pair, then also return false. And the third case is if both the cases are not there, then return true. It means exactly one set bit pair. Now, for that, if we are considering the number to be a 32-bit integer as is given here, so what I'll be doing is for checking if a bit is set or not, what I can do is um, okay, I can take a check bit, sorry, chk. uh, Still not there. Uh hello. Okay, chk check bit that is equals to 1. And for each for each bit, I have to check by using the right shift operator and doing AND. How will I check? First of all, how to check if a bit is set or not? For checking it, let's assume that the number 110 is represented, which is equal to 6 in this form 110. So for checking it, what I'll do, I'll have my check bit 1, which is initially 1. So what I'll be doing, I'll be shifting this 0, shifting this check bit one place, and I'll check if the end of current bit and our check bit equals to 1. That means our bit is set bit. Correct? You got my point, na? If current bit, for example, 0 and check 1 equals to 1, which is not 1 here, so it's not a set bit. In this way, we can check if the bit is set or not. Now, the second thing is how to how to track uh, consecutive set bit. How to take consecutive set bit. So what I'll be doing, I'll be taking uh what can I say? Uh Count. Let's say count, which is initially 0. Now, if we are able to find the value of count, then what we can do in the end, if count equals to 1, then what will we do? Return true, else return false. In this way, we can do this. So let's take one more variable, that is count, that is equals to 1. And at the end, what I'll be returning, return count equals to 1. This is the only case where we have to return true, otherwise false. Okay, now this is the logic part. Main logic comes here. How we are gonna iterate over all 32 bit. I'm considering it's an integer, so it will be having 32. Okay, so what I'll be doing is 0 to 31. Okay, so for I in range 32, so it will be going from 0 to 32. Now I'll check if I'll take a counter previous, which is which is to check if the previous bit was 1 or not. Previous one is previous 1, which is false initially. Okay, this is just to track if the previous bit was 1 or not. Okay, okay, currently it is false. Okay, so what I'll be doing is, I'm sorry, what I'll be doing is I'll try to end. Okay, right shifting. First is check equals to check, right shift by I, or I can say I will do it directly now. I'll do it directly. I'll do it like check left shift of I. So I is starting from 0. So for the first case, it won't be changing. So if it's equals to 1, if it's equals to 1, okay. Now we can have two cases here. I can explain you the cases. For example, we have 1 1 1. So our check bit is 1. So what we are doing, we are trying to check if the end of this one and this one equals to 1. Okay, that's we are trying to check. So if it's equals to 1, our previous bit, which is previous bit, we'll check for previous bit. For example, I am here, this bit was already checked, and is previous one is true. Okay, so in this case this is true, so I'll be checking that if the previous one is true, then we have to count, we have to increase the count by 1. Okay, yeah. Now if is previous previous one, then count plus equals to 1. It means the previous bit is 1 and current bit is also 1, so it is a consecutive set bit pair. Correct? Correct. Now the second case is, uh the current bit is 1, and the current bit is 1, and we already checked that the previous bit is 1, then we have to increase the count. Otherwise this will be our first bit, that is 1. So what I'll be doing, else, in the else part I'll be doing is previous 1 equals to true. You got my point, na? This is the case where the previous bit is already 1, so we are getting a consecutive pair. So I'm increasing the count by 1. I'm writing here the comment, got a consecutive set bit pair. Got it, na? In this way we can do. Now in the previous bit, if the previous bit is not 1, then here we are assigning that the previous bit is 1. Else, 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 else case will be when this is false. When this is false. Correct? I'll take these inside a bracket. Correct? So else will be the case where this is false. So when it is false, we have to set is previous 1 equals to false. Correct? Now we are getting this, the previous bit is not false. In this way we are able to check that the previous bit is true or not. Correct? You got my point, na? Okay, so I think that's all the logic is. Let's try to check true and true. Okay, so it is coming true for 5 as well. I think I'm missing some sort of edge case. So for 5, what will be the answer? Count is equals to 0. Okay, now check. Now check. It is false and it is also false. Okay, check bit is 1. So we are left shifting check by 1 and then doing it right this. Uh, can we do a dry run here? Can we do a dry run here? Of course we should do. I'll be going with 6. So 1, 1 and 0. Our check bit is 1, which is currently here. Correct? So I'll come here. I'll check for each and every bit. I'll check for each and every bit. Okay. Now our check is already 1. So what I'll be doing is check left shift of I, means check left shift of 0. So it will be here only. Now I'll be ending it with 0, and check bit is let me write it here. Check bit is 1, and count equals to 0. Let me check if is there any comment right over here. Sign into chat. Okay, I'll do it from the next stream, I guess. Let me check whether I'm live or not. This is a very good question, by the way. I'm actually liking it. and I'm streaming here, just to tell you that how I approach and how you should approach. Okay, Atul Kumar Gupta. Let me check. Okay, I'm live. I'm live. No issues. So we were running this now. We were running this test case. Let's assume that yeah. So is previous one is equals to false by default. Okay. So what we are checking if n and what we are checking is our count is 0, our check is 1, our is previous one is already false. Now we are checking for 6. So 1 1 0. Okay, and we'll be going for 0 till 31 because we are considering that the integer will have all the 32 bits and we have to check for all the consecutive and non-consecutive bits. So that is how we are checking. So yeah, its previous one is by default false, one is here, 0 and 1 is 0, so it will come here. Previous one is all it is again false. Okay, now I will increase and check left shift 1, so this will come here, correct? Now 1 and 1 will be 1, so it will go inside this loop, but the previous is not 1, the previous is not 1. So what it will do, it will do nothing, just make the previous from false to true, correct? Now I loop again continues and it will go for this one, correct? When it will go for this one, it will check that n and check of I is equal to 100%. Now it will check if the previous one was 1. Yeah, 100%, it is true. So the count will be increased by 1, correct? So our count will be increased by 1. Okay, now the loop will go till 32 and we won't be finding anything. Why? Because this will have a lots of leading zeros till 32 and this will be here. Okay, so every time it will be false, so if the previous one is will be set to false thereafter, so there is no case in which the count will be increased. So we are at the end checking if the count is equals to 1, then return true. So I think the dry run is actually correct, but I don't know why I'm getting wrong answer. Okay, okay. What should I do now? What should I do now? I should oh, nice. So let me okay, let me check, let me think about it. Okay, this was the mistake. What I was doing is I was checking for one, but this case will not give the answers as we were expecting. Yeah. So I think it should work now. Or the correct logic for this can be if what we'll do if we try to left shift the number by I place. Okay. And then we are doing end with one. If it's one, then it is also a good case. I mean, we're taking it to the first place and then ending with one. So I think it should work now. Yeah. So let's submit this question and see if it's working fine. Okay, we finally submitted this question. Just a little bug right over here, and we are able to solve this question. Okay, now we are going for the next question. Okay, so I'm not aiming to solve all the four questions, but whatever I'm solving, I want that the intuition should be 100% clear. You got my point. How we'll approach in an interview, or we are giving an exam. That's what I'm showing. How I think, how you should think, and also you should tell me what's wrong I'm doing. So yeah. So minimum energy to maintain brightness. So you are given an integer n representing n light bulbs arranged in a line and index 0 to n minus 1. Okay. So you are given an integer n representing n light bulbs arranged in a line. Okay. Got it. Now you are also given an integer brightness and a 2D integer intervals, where intervals of I is equal to okay represent an inclusive time interval during which the like okay, got it. So at the time you at each time unit, every bulb can independently be off or on. A bulb that is on illuminates its own position and its adjacent position if they exist. Okay. The total illumination at a time unit is the number of illuminated positions. Each position is counted at most once. Okay. The total illumination at a time unit is the number of illuminated position, and illuminated positions are that position plus adjacent. Each position is counted at most one. For every integer time unit covered by at least one interval in I guess my camera is on or not. Let me see. Okay. Okay, return an integer denoting the minimum total energy required. Okay, so for every integer time unit covered by at least one interval in intervals, the total illumination must be at least brightness. Should we solve this question live, or I have to check what is the stream timing right now? So I was streaming since uh, 23 minutes. So should we stop here? Because I want to stream tomorrow's contest. So I think we'll solve tomorrow's questions, weekly contest questions. I'll woke up early and then we'll solve it live. So yeah, I'll be solving these questions, but yeah, later worse. So that is it for today, guys. So I'll meet you tomorrow morning. And yeah, so bye bye.